Today we are going to start previous year questions from GATE and IES exam. All the questions which are on direct formula and theoretical are already covered in my previous theory lectures. Now you will see how questions have been repeatedly asked in GATE and IES exam. So first we will start with ES and GATE questions on characteristics of switch. To know more about these concepts or theory behind these questions, you need to refer lecture number 4 of my theory. So start the lecture.
Now we will solve this question that has been asked in GATE 2005. Here this characteristic is given. Here voltage changes from V to 0 and current changes from 0 to I, and we have to tell whether the process is turn on or turn off and what is the energy lost during transition. Here transition means change in voltage from V to 0 and change in current from 0 to I. So first this we have to find what is this process. We know that during turn on the voltage drop across a switch is nearly equals to 0 and current through the switch is maximum. So here we can see that after T2 the voltage has become 0 and the current has becomes I. That's why this process is turn on. So answer of first part of question is this is a turn on process. Now what is energy losses during turn on? Here energy losses E is simply given by formula VIT. So first we will find the energy losses during transition that is happening over period T1. So during T1, suppose energy losses are equals to E1. So here we see that during period T1 this voltage V is constant. So we simply write V into what is IT? Okay, IT means area under this IT curve. So area under this IT curve will give the IT. So area IT curve. So what is area under IT curve? That is equals to V into, this is a triangle and area of triangle is half base into altitude. Here base is T1. Okay, this is base. And what is altitude? That is equals to I. So we get Vi by 2 into T1. Now during time T2, suppose energy losses are equals to E2. So but during period T2 we can clearly see that this current I is constant. So we can write I into area under this VT curve. So it will simply gives VIT, same thing. So area under VT curve, what is area VT curve? Okay, now what is area under VT curve? It is simply equals to half base into altitude because it is a triangle. So half, what is base? Base is equals to time T2 into T2 into altitude. What is altitude? Altitude is voltage V. So on solving this we get Vi by 2 into T2. So total energy losses will be equals to E1 plus E2, that is equals to Vi by 2. Take sum of these and take Vi by 2 common. So T1 plus T2. So answer is energy losses are equals to Vi by 2, T1 plus T2, and the process is turn on. Now see this question that has been asked in GATE 2016. This question is based on the switching characteristic of thyristor. Here in this question we have to find the energy dissipated during turn on in millijoule. Here voltage waveform is shown and here current waveform is shown. Okay. Here initially the current was voltage was 600 volt and it finally becomes 0 volt, and initially current was 0 ampere and finally it becomes 100 ampere. So this process is clearly turn on. Okay, now we have to find the energy dissipated, or we can say that we have to find the switching energy losses. Okay, and we have to find switching losses in millijoule. So we know that energy is given by, sorry, energy E is given by VIT. So first we will take period T1. Suppose energy losses during T1 are E1. So here we can see that during period T1, that is equals to 1 microsecond, the voltage V is constant, that is equals to 600 volt. Okay. Now what is IT? IT is simply area under this IT curve. Okay. Area under IT curve. Okay. So it simply gives IT. So E1 is equals to V is equals to 600 volt, that is constant. And what is area under IT curve? That is equals to half base is equals to T1, and that is equals to 1 microsecond. So 1 into 10 to the power minus 6. Okay. And what is this altitude? That is equals to 100 plus 50. 100 plus 50. So here we get 600 by 2, that is equals to 300 into 10 to the power minus 6 into 150, 45. So simply we get 45 millijoule. Okay. Now during time T2, see the waveforms. During time T2, this is time T2, and during this time, okay, during this time this current is constant, and that is equals to 100 ampere, but this voltage is time varying. So we can write energy losses during time T2 is equals to again VIT, and here current I is constant, so we can write and what is current? That is equals to 100 ampere. Your current is 100 ampere, so simply 100 into area under VT curve. So it will give VT. So simply we get VIT. Okay. So what is area under VT curve? That is equals to this area. That is equals to half base into altitude. Here we get, sorry, this is 100. Here we get 50. So here we get 30 millijoule. Okay. So now what are total energy losses? Total energy losses are equals to total energy losses. Here we can write E is equals to E1 plus E2. What is E1? That is equals to 45, and what is E2? That is equals to this 30 millijoule. So we get 75 millijoule. So answer is 75 millijoule.
If you got the knowledge and concepts from this video, then please like the video and subscribe the channel. You can give your views and ask any questions related to this topic in comment box. Also share this video with your friends because sharing is caring. Don't forget to press the bell icon to get the notification of my upcoming videos. Thank you.